Morning. Am I audible to you guys? So in last class, we mainly discussed about the starting of the DFA. We learned about transition diagram and transition table. So today I'll just start with the example first. To this example, we'll see how we can construct or design DFA from the language. So right now I'm just give you an example with suppose for example a transition table is given and we have to construct the diagram. So for example there are two input symbols 0 and 1. So first column is for input 0 and here input 1. Remember these two are next state. Okay, these two is next state. This table is already given. Just so just think this table is already given and you need to design the DFA from here or the transition diagram from here. So from the table, what are the information you have? There are three states, right? You simply write three states. Q2 step, Q0, Q1, Q2. Okay, three states are already here. So first, just write three states. So now we know Q0 is the initial state because the indication is with the arrow. So this is the initial state, and with the star, we know Q2 is the final state. So make it in a double circle. Now you see from Q0, if we take input symbol 0, then it moves to state Q1. That means if we take or read input symbol 0, it goes to Q1. Then from Q0, it's written if we take input symbol 1, then it moves to Q2. That means if I take input symbol 1, it moves to Q2. So this row is done for Q0. Q0 takes input symbol 0 and it moves to 1. If it takes 1, it moves to Q2. Okay. Next, come to the next row. So for Q1, if it takes input symbol 0, it moves to Q0. That means from Q1, if I take 0, it goes to the Q0 again. Now for Q1, if input symbol is 1, it goes to Q2. For Q1, when it breaks 0, it goes to Q0. And it takes Q1, it goes to Q1. Okay, this flow is done too. Now for Q2, if it takes 0, it comes to Q2 again. So just make the self. So from Q0, if it takes 0, it comes back to Q2 again. And if it takes 1, it again comes back to Q2 again. So whether it takes 0 or 1 in both ways, it comes to the Q2 again. Okay. So this is your final DFA for the given transition step. Is this one clear? Is this example clear? Transition table is given, how you need to map the given input with the next step, and accordingly you have to draw the DFA. Everyone, Rida? Do you want me to repeat or it's fine? Here. Address. Actually, solution is you can see first time in the class. Okay, so you said here. So I move to next one. So this time I'll give you the diagram, then you have to make the table. This time I'm just giving you a diagram. So, for example, this diagram is given and you need to make the table. So in the table, how many states are there? States are there. And what are the states? This part is present state. How come 3 states? How many states? 1, 2, 3, 4. there are four states. So what are the states? We have Q0, then we have Q1, then we have Q2, and we have also Q3. Okay. So from the diagram, we know Q0 is the initial state and Q3 is the final state. Right? So let's start from Q0. So from the diagram, when it reaches 0, what is the state, next state for Q0? When it reaches 0, it comes back to Q0 again. Correct? So next state for Q0 after taking 0 is Q0 itself. Now what's the next step for Q0? When it reaches 1, it goes to Q1. You just need to follow the arrows. Okay, just follow the arrows. Okay, so this row is done. Okay, now come to Q1. So for Q1, if it takes 0, where is it going? See, it's going to parts. Once it is going to the Q1 itself, and once it is going to Q2. Right? For 0, in one way it comes to Q1 and again it goes to Q2. So you have to write Q1 and Q2. So from here, you know that it is not here. This one is NF, non-deterministic automata. For DFA, for one input symbol, it goes to one state. But for NFA, it's not like that. For one input symbol, it can go to any state. So from 0, by reading 0, it comes to the Q1 and again it can also go to the Q2. There is no definite, like in DFA for one symbol, it can go to only one state. But in NFA, for one symbol, it can go to any state. So this one was the example of DFA. Because for every input symbol, it just changed to one state. But here, for one input symbol, it can go to more than one state. 2, 3, 4, 12. Okay. So now see, if it takes 1, where is it going? From Q1, if it reaches input symbol 1, it goes to Q. Okay, just 1 this time. So this one is done. Now you come to Q2. For Q2, if it takes 0, where is it going? From Q2, when it takes 0, where is it going? From Q2, if it takes 0, it comes back to Q1 again. So Q1. Okay. Now from Q2, if it takes input symbol 1, it goes to Q3. Okay, this row is also done. Now for Q3. For Q3, if it takes 0, it goes to Q2 again. Okay, and for Q1 also, it goes to Q. Okay, so this is the transition table for the given transition diagram. Is this one clear? So questions can be in this way. Maybe a diagram is given, you have to meet the table, or table is given, you have to draw the diagram. Clear? So I guess both was clear to you guys, both transition diagram and the tape. Okay. Now we will see how to construct DFA if just the conditions are given. Okay. This is the simple way. The diagram or the table is given, you can do both. Okay. But in real way, mainly they give a grammar or they just input symbols, then they provide just example. Okay, some conditions are given, then you have to draw. Okay. Now, what was the formal definition of DFA? How many tuples? How many tuples? 5. What are those? Q, set of all states. Then sigma, set of input states. And what? There will be a initial state, there will be a final state, and there will be a transition function. What is the transition function for DFA? It will, from one state, it will take one input symbol and will move to another state. This is the transition function for DFA. Okay. Now, example are like you have to construct a DFA with input symbol, for example, 0 and 1, accepts all strings starting with 0. Okay. Question will come like this. You have to design a DFA with the input symbol 0 and 1, and it will accept all strings starting with 0. Now there is no transition table given, but you have to construct it here. Okay. So what you have to do in this case is, from the condition, you have to find out what could be the possible strings. Okay. So your input symbol is given 0 and 1, and it's written all strings starting with A, starting with 0. So what can be the possible strings here? Possible strings starting with 0. So there will be at least one 0. Correct? This will be accepted. It's starting with 0. Then it is also possible it will accept 0, 1. Okay. Starting with 0, satisfying the condition. It is also possible it will go like 0, 0, 1. Starting with 0, accepting it. Okay. It is also possible you can write 0, 1, 0. It is also accepted starting with 0. You can also write 0, 1, 1, 0, 1. This is also accepted because starting with 0. So tell me if this string is accepted by DFA 1, 0. This string will not be accepted. Why? Because here starting with 1, but the condition given is there all starting with 0. So this string will not be accepted. 1 will not be accepted. 1, 1, 0, 0 will not be accepted. Correct? So any string starting with 1 will not be accepted, and any string starting with 0 will be accepted. So it will be infinite language. Okay. You cannot just define how many one will be there, how many zeros will be there, and what will be the sequence. There is no sequence given, just that it should start with zero. Okay. Now, how will you draw it? So there will always be a initial state as per the rule because it's a 5 tuple, correct? So this is the initial state. Okay. So always start from the minimum string. What is the minimum string here? 0. 0 should be accepted by the DFA. 0 is the minimum string. So Q naught after reading 0, it will go to the final state. For example, this is Q1 state and it is 0. So this one is accepting. It is in one state. After reading string 0, it moves to the final state. So this is done. Correct. Now for Q1, but there are also conditions like there can be multiple zeros. There can be one also. Correct. So from here, if I make a self loop and say 0 and 1, it is accepting all states. Correct. For example, 0, 1. So from Q naught, it is taking 0. It moved to Q1. Okay. Then again, it comes to 1, then 1 again. So you read to 1 again here because it's a self loop. So after taking 1, it will come back to Q1 again. So this one is accepted. Right? Suppose if you take 0, 0, 0, 1. So you can move like no, it coming to Q1. From here again it can take 0. It's a self loop. Doesn't matter how many times you read the 0. Okay. So you can read 0, move to Q1. You can again read 0, again move to Q1. Then we take 1 will come to Q1. So Q1 is the final state. So this one is accepting. So similarly, no matter what is it, with this self loop, you are this, it is coming to the accepting state, correct? And it is starting with a 0. Any string, it will start with 0 and it will reach the final state. Minimum string is the 0. So is this one complete? This one is not exactly complete, right? From 0, we have considered only for the input symbol 0, but we haven't considered the input symbol 1. For Q1, we have considered both input symbols 0 and 1. It finally reached to Q1. For Q0, we took 0 and moves to Q1. Now for 1 also, we have to provide a state. So DFA. For every input symbol, it must go to another state. So it is 1. Okay. This is more like a dead state. You cannot go anywhere from this one. Okay, this is a dead state. So for example, you are trying to accept this one. Okay. So after reading 1, it is not going anywhere. It is just stuck there. Okay. So it is not reaching the final state. So it's not accepting any string with any string starting with 1. Okay. Is this one clear? So this is the DFA. for a string which will start with 0. Okay. In some places you will see people also make a self loop here and write 0 and 1. This one is also correct. Because see, for every state we are saying that both symbols should be utilized. For Q2, I didn't write the symbols Q, not and 1. Correct? So you just make a self loop here, and no matter what is the symbol 0 and 1, it will remain in Q2. So for example, you are reading 1102. So after reading 1, it will come to Q2, Q0. It's reading 1, coming to Q2. Okay, from Q2 again, it's reading 1 and it is coming back to Q2 again, and it's taking 0 again in Q2 and again in Q2. So it is not a final state, so these strings will not be accepted. So all the strings which will reach the final state, only those strings will be accepted. And all these strings are starting with this part clear. This example. This string will accept with 0. Yeah, it will accept all strings starting with 0. This one example. Clear? How many strings? You just need to see the pattern and look at the conditions. Okay, this one I am showing you only for the understanding. Main diagram is this part. This is just a small diagram. So in this diagram, you are just accepting every step. You have to make sure all the possibilities are clear. So if it is starting with 0, so after reading the 0, it reaches the final state. Then you make a self loop here. After this, doesn't matter which part, which symbol it is taking. Okay, 0, 1, 1, 0. Sequence doesn't matter here. So only condition is starting with 0. So it will always start with 0. Correct? See this part here. Okay, let's see another example. Okay, let's take another example. Now we have to construct DFA with input symbol A and B. Okay, it will accept all string ending with 0, ending with A. Okay, In previous example, I showed you starting with 0, and here I'm showing the ending with 0. Just that input symbols are different. So what can be the possible language? Ending with A. Okay. So A should be accepted. Right? There can be double A ending with A. That can be triple A ending with A. Accepting. There can be 4 A's still accepting. Okay. Then also B is correct. Starting with ending with A, then B B A B A, then A B A, then A B B A. Any sequence, any strings ending with A. Okay, these strings are accepted. Again infinite. But any string with A B, B A B, A B B, these are not accepted. Why? Because these are ending with B. Okay. So how will you construct it? As usual, there will be initial state. Okay. Minimum string is what? A, ending with A, starting with A and ending with A. So after reading Q0, it will go to Q1, Q1, A. So this one is accepted. Okay. Now from here, if you make the self loop, all A's are accepted. A, A, double A, triple A, 4A, 10 times A, 100 times A, all strings will be accepted. Right? Anything ending with A, like this type, A, single A, double A, then again triple A, 4A, any numbers of. So this type of strings are done. Okay. Now there can be also strings that can start from B but ending with A, right? So if I make a self loop here, B, so it will read one B and reach BA, suppose BA. It reaches the final state, right? Then there can be multiple numbers of B in front of A, doesn't matter. So it will be also accepted 1B, 2 times B, 3 times, 4 times, 100 times B. Then at last read A and reach final state. Okay, then again there can be like hundreds of A's after that. So 100 times B, A, 100 times A. This one is also accepted. Done. So for Q0, we have done the transition for both symbols A and B. After reading A, it will go to the final state, and after reading B, it will come back to Q0 again. Okay. Now for Q1, we have done the A part, we haven't done the B part. Can I make a self loop of B here? Can I make a self loop here for B? Can I do this? Can I do this? Can I write a B here? Like previous one. If I make a self loop B here, then any string ending with B will also be accepted. Suppose AB, A and B will read and it will be accepted. But that's not the condition. It should be ending with A, not with B. It can also accept ABB. How? Will read A, then B, and B. So A is Q0, Q1, Q1. So this will be accepted. But that's not the condition. Right? It should always end with A. So we cannot do this. We cannot do this B here. We cannot make a sample. Instead, if you bring it back to Q1, the problem is solved. Correct? If it reads from Q1, if it reads B, it will come back to Q1, which is not the final state. So after that, anyway, it has to read A, then only it will read the final state. So here it's solved. Any string that will be like ABB, it's reading A, then it's reading B. Now Q1 here, it's reading B again, self loop here, Q0. Again, it's reading A, so it's the final state. Right? For ABB, what will be done? Q0, A, Q1, then it reads B. Then it will go to Q0 again. Okay? Then from Q0 reading B, it will go to Q0 again. Okay? Then it has to read A. Then only it will come to the final step, which is Q1. So any string containing A, B, any string is there, N will always start with A. Means ending will be always with A. Got the idea? Got the difference between the previous and this one? Here I made it self because our condition was starting with 0. So it doesn't matter whether in the end there is 1 or whatever. The starting is always 0. But here I am saying ending should be A. So I cannot make a self here. So I bring it back to the Q0, which is not a final. Then again, any whatever it is, it will read A only and will reach the final state. Is this example clear? Others? What about the Pashri, Abdullah, Chunjima, Tamar, Yogesh, Roji? Are you guys following? Any confusions, anything? If you don't understand, simply ask. Okay? Want to repeat me? Then just tell me. It's fine. Yes, yes, ma'am. Okay, so I guess these two examples are clear to you guys. So I am ending the class here. Next class I'll start in my time. Okay? We will see a bit more complicated one. Okay? Stop sharing. Let me take attendance. दो लोग कोई लीव मार के अटेंडेंस मिलेगा नहीं. And thank you. See you in class. Take care.
Thank you, ma'am.